ladies and gentlemen, we all know how I feel about LeBron James. So, angle measures, okay? This is what I noticed as I saw some of your shapes. Some of you had convex polygons, and the other half of you had concave polygons. Now, if you're looking at the paper that I gave you, in the bottom left-hand corner is our first slide. And then we go up, over, down. Okay? So for some reason, I don't know why they printed weird right there. Okay? But the difference between a convex and a concave, when you think of a square, that is convex. When you think of a rectangle, that is also convex. Okay? Oh, hey, that was mean. I would draw these pictures. Okay, so notice that for a convex polygon, if I start at any vertex, at any corner of my shape, and I want to go to another corner of my shape, most of the time I'm just going to travel along the outside of the shape, right? Or I might be able to do like a diagonal to the other side. I can do that. But when I have a convex polygon, I'm staying inside of the shape.
So convex, you always stay inside?
Yep. Concaves. These are the types of shapes where if I had Slade's artistic ability, I would attempt to draw a star for you. Oh, yeah. Okay? So here's my example of a concave polygon.
Hey, that looks like ours.
Okay? Pretty good, right? It's pretty fantastic.
Can you
Ladies and gentlemen, by definition, it is a polygon. It is a closed shape. There are straight sides. So by definition, that is a polygon. Okay, well, as straight as I can make the sides, right? Concave means that I can travel outside of my shape to get from one point to the next. Okay? So notice how those red lines are actually outside of my polygon. Okay?
How can you tell the difference?
What do you mean, how can you tell the difference?
No, I mean, not between that, but I mean, how can you tell if it's concave or...
Literally like that.
If it travels inside.
If it travels inside or if it travels outside.
Wait, to get to the angle?
Yeah, so to travel from one angle to the next, if I go outside of the shape, it's concave. Okay? Ladies and gentlemen, how do I feel about this? Do we feel okay? Yeah. All right. So ladies, we do have multiple types of polygons. Okay? Multiple types of polygons. If I say equilateral, what comes to mind?
They're all the same.
What's all the same? The sides. So ladies and gentlemen, in equilateral triangles, an equilateral polygon has the same side lengths. Think of a square. Think of a rhombus. Well, they wanted to do a rhombus earlier, so I'm just throwing it out there. Okay? So equilateral polygons have the same sides. If I say equiangular, what do you think of? All the angles are the same. So think of a square. Think of a rectangle. All the interior angles are the same. Right? Okay. If a shape in particular is equilateral and equiangular, we call them a regular polygon. Okay? So squares are a regular polygon because all the sides are the same, all the angles are the same. A hexagon. Okay? All the sides are the same, all the angles are the same. A pentagon. Sides are the same, angles are the same. Okay? Questions, comments, or concerns? We feel okay? You're welcome. All right. So, to answer your burning questions, Miss, how'd you do it? Polygon interior angles theorem. Okay? How did I find the interior angles of every single one of your shapes? Okay? So, the sum of the measures of the interior angles of a convex n-gon. Ladies and gentlemen, what do you think n represents? Number of what? Sides. Ladies and gentlemen, n is the number of sides.
I'm just kidding. N equals number of sides.
Okay. So, ladies and gentlemen, n is our number of sides. The formula that I was doing I'll stop. Any shape that I give you, this is the formula I was using on my calculator as you guys were telling me the number of your sides. N minus 2 okay? N minus 2 times 180 every single time. Okay? What?
If you had something bigger than like 12...
You can still do it. Doesn't matter how many sides you have, Gerald. Okay? N minus 2, number of sides. N minus 2 times 180. It'll tell you the sum of your interior angles. Yes.
Oh, so you use it to find the sum of interior angles?
Yes. So this is the sum of interior angles. Yes.
Is that just for convex or is it
Yes.
for
Okay.
convex?
You can use it for concave. Yeah. Okay. So ladies, here are some examples. Find the sum of the measures of the interior angles of the indicated convex polygon. So looking at number 3, because I know you have this. Nonagon. By definition, for those of you who don't know, nonagon has 9 sides. Okay? 9 sides for a nonagon. Okay? So all I'm going to do is plug that into the equation. Okay? So we're going to 9 times 180. No.
I'm sorry.
What is 7 times 180?
7 times.
What is it?
1260.
1,260.
Hey, I was close.
So ladies and gentlemen, what I know is that if I gave you a convex shape that had 9 sides, all of the interior angles add up to 1,260. Okay? That's just adding them all together.
Can you divide by 9 and find the individual?
Divide by 9 to find the individual.
I'm so smart.
Okay? All right? Okay, I don't remember exactly where I left off with this slide because it's been a few hours, but we plugged in the number of sides, minus 2 times 180 equals 1260. And if I go over here to the 14 gon, I know the number of sides is 14. So we're going to take 14 minus 2 times 180. So we have 12 times 180 is 2160. You can do the other two for extra practice if you'd like, but I'm not going to go through them just to save us some time. All right. The sum of the measures of the interior angles of a convex polygon are given. Classify the polygon by the number of sides. So now we're going to work backwards using the fact that n minus 2 times 180 is our sum. Okay? That's our sum formula, so we're going to use that and we're going to go backwards. Okay? So looking at the first one, and I'm skipping number 9 and number 10. So I'm just going to work out number 7 and number 8. So looking at number 7, I'm going to set this equal to n minus 2 times 180. Alright, so to solve for n, the number of sides, we're actually going to divide both sides by 180. When I do that, I end up with 4 equals n minus 2. So to get n by itself, we add 2 to both sides. 6 equals n. So I have 6 sides, also known as a hexagon. Okay, so for number 8, we have 1080. Set this equal to n minus 2 times 180. Divide both sides by 180. So 1080 divided by 180 is 6. So 6 equals n minus 2. Add 2 to both sides, I get 8. So I have 8 sides, and that is an octagon. Okay? And you can do number 9 and 10 if you want additional practice again, but this is just us working backwards to get n by itself. Okay? So we need to find the missing interior angles. So the first thing that I'm going to do is figure out how many sides I have. 1, 2, 3, 4, 5. So n equals 5. Okay, so the first thing that I'm going to do is figure out what the sum of all the angles of a 5-sided convex polygon is. So 5 minus 2 is 3. 3 times 180 is 540. So I know that all of these angles together have to add up to equal 540. Okay, so I don't know these two angles, but they look like they're the same. And I know they're the same because they have the same little red dash marks there, so I'm going to call them X. Okay, so now we're going to add up all of our angles together, because together they all have to equal 540. So we have X plus 90 plus 164 plus 102 is 266. Let's keep combining like terms. 2x equals 2x plus 356 equals 540. So let's go ahead and solve for x. So we subtract 356 from both sides, and that gives us 184. So 2x equals 184. Divide both sides by 2. So x is 92 degrees. Okay. Looking at number 20. It looks like 1, 2, 3, 4, 5. There's still 5 sides, n equals 5. So I know again that all of these angles, when I add them together, are going to equal 540. So we have 2x, because I don't know angle y or angle x, 2x plus 47 plus 119 plus 90 equals 256 equals 540. Okay, so I subtract 256 from both sides. I get 284. So 2x equals 284. So when I divide both sides by 2, I get 142. Okay. The next one tells me it's our exterior angles theorem. And this is important because it tells me the sum of the interior angles. So the sum of the measure of an exterior angle is 360. So that means every single one of the exterior angles has to add up and equal 360. Okay? So look at this one. I'm only dealing with exterior angles, so I know that I can add them together and they'll all equal 360. So x plus 65 plus 106 plus 78 has to equal 360. So 65 plus 106 plus 78 is 249. So x plus 249 equals 360. If I subtract 249 from both sides, I get that x is 111 degrees. And I'm going to do the same thing for number 24, except I'm going to add them all together beforehand. I know they have to add up to 360, so I'm going to take 59 plus 48 plus 50 plus 39 plus 58 is 254. And then I have these two x's there. And if there's two x's there, I know that they're congruent to each other. So I have this 2x plus 254 equals 360. So if I subtract 254 from both sides, I get 106. So 2x equals 106. So to get x by itself, we're going to divide both sides by 2, and I get 53 degrees. Okay, and this last one, we're going to go ahead and skip it for now.